good. Hi, everyone. You're in the Elasticsearch talk. I hope you wanted to be here. So, I'm Philipp. I organize meetups. I do lots of conferences. So this is kind of my thing, so I'm happy to be here and talk to you about it. And I work at Elastic in the infrastructure team. So my team provides the infrastructure for the rest of the company. So we do stuff like Docker, Jenkins, AWS instances. And when I'm not part of the infrastructure team, I'm out doing talks quite a lot. Yeah, so who is actually already using Elasticsearch? Okay, a few. Who is using Logstash and Kibana? Okay, also a few. Is anybody already using Beatz? Ah, very nice. Yeah, so just to clear up a bit of the confusion, because it's Elastic, Elasticsearch, Elasticstack, it's very hard to get kind of the terms right to know what we're talking about. So first off, Elastic is the company behind all of the technology. Elasticsearch is where you actually store your data, and the Elasticstack is then the full stack of software we provide, just to make that clear from the beginning. Okay, so let's start with some history. Back in 2010, Shai Bannon started on Elasticsearch, but he even had two products which were also doing full-text search before that. Those were Compass 1 and Compass 2, and each time at some point he saw that what I've been building is working somewhat, but I need to re-architect and make stuff better. And this is kind of the third iteration now, which is Elasticsearch, started in 2010 with the company Elastic behind it, founded in 2012. And actually the story why he started doing that is pretty funny. His wife was, or is, a chef, and she moved to London. And he didn't get a proper job in London, and he thought about how to help out his wife. And then he built a full-text search engine on top of Apache Lucene to help her search her recipes, so she could, if she has some ingredients, she could actually look up what can I make out of these ingredients, which is kind of how he got started with the full-text search thing, which now developed into Elasticsearch. So it is based on Apache Lucene, which is doing the hard indexing stuff at the bottom. So this is like for full-text search, you have stuff like stop words. You remove the little words you have in the language which add very little meaning, but it's just like unnecessary overhead you would need to carry around. You have stuff like stemming, so cutting off the ending of words just to get down to the concepts, because if you're searching for something, you're most likely interested in a concept and not in just the specific form which you're looking for. This is also the big distinction to a database. In a database, you're most likely searching in a black and white fashion. You have a query, and everything matching that query exactly you want to have back, and everything not matching that query you're not interested in. Whereas Elasticsearch or any full-text search engine is much more like shades of gray. So you have documents which you have indexed, and then you have queries coming in. And then you get results which are matching your query better or worse, and you always have like a quality of those search results. We have that as the _score field, where we can actually sort like how good is the quality of the documents we have found for you for your actual document. So this is the main contrast to a database like relational or NoSQL database, which is just like find me exactly this stuff I'm giving you. And full-text search is much more about these shades of gray. Even though Elasticsearch can also filter, so you can use it for many use cases you would want to do with a database as well. And the slogan of this one was, for search. And this was very nice and developed nicely. I'm sure pretty everybody knows these three logos. If you search on any of these sites, the search will actually go through Elasticsearch. I guess nothing else to add here. And then people started building other products around Elasticsearch. And two of them were acquired or kind of joined the Elastic family. This is also why the company at first was called Elasticsearch, when it was only Elasticsearch, and now it's called Elastic because there are other products around it. So first off, Kibana, which is kind of the window into your data. You can use it to explore your data or visualize or graph it. So it's just for people wanting to have some insight into the data. And it's also very nice to have the big TV screen in your office and display whatever metrics are relevant for you. So in the ops room, for example, you could put up like, we're getting that many requests per hour and we're serving that much, I don't know, requests or traffic or whatever per second. And you could get all these metrics. And the business people would want some different metrics. Like you could insert your sales data and then you can display, okay, today we've sold these many pieces from our shop or whatever your business metric is. So this is what Kibana is. It's just a visualization of your data. And then there is Logstash, the log. This is if you have a lot of logs, like most people do, especially if you're going towards the microservice world where you have many servers and everything is highly distributed. Just tailing a file or grabbing in a file on one server doesn't really cut it anymore. Because if one request touches 10 different servers, because you have 10 different microservices interacting, you would need to log into those 10 different servers and then grab or tail 10 different files, which is not all that practical. So therefore, there's Logstash, which kind of takes the logs from one server, parses them. So you have something we call grok, which is basically grep. You have your patterns, and you know, this is my Tomcat log, and it's structured like this, and then you can extract the relevant fields. And then you can insert that data in a more or less structured form into Elasticsearch and have that aggregated centrally, and then you can also search through it centrally. So using Kibana, you can then search through your log files in one place, and you don't need to log into 10 different servers to get an overview of your system. And this was the Elk stack, Elasticsearch, Logstash, Kibana, and it had a very nice mascot. It was a Plushie Elk, so a little toy you could have. But unfortunately, the elk is now retired. So just to put in some more information into Logstash, these are some of the, I think there are like 200 ways to ingest data in Logstash. So you have the very low-level ones I put on top, like syslog, standard in, files, Unix pipes, TCP, whatever you want. These are the methods to get your data in. You can also consume from queues or write back to queues. If you have a very high volume site, you might want to do that, not to overload any component, and just throw everything into a queue. And as soon as you can consume it, you just take it out of the queue. And you can also aggregate data from higher level services, like you could ingest tweets or meetup.com or GitHub pushes or whatever you want to do. And this is also very popular. Like CERN is using it. They have thousands of servers just to do all their computation, and they use it to ingest the logs from all of these servers and have a centralized overview over them. Salesforce is also using it to aggregate all the overview of their cloud service, and Goldman Sachs is betting very big time on Elasticsearch just to have a general overview over their business. So they have been misbehaving in the past, every now and then, like doing some, I don't know, inside trading or whatever, and they have been fined pretty big time. Like every now and then they need to pay $100 million in compensations for screwing up. And at some point they decided, like, this is probably not worth it. Put all this stuff into a centralized store and have proper audit and compliance logs over that, so we can actually stop bad stuff happening because we're being fined again. So instead of paying a fine for $100 million next time, they are just investing a few million into a proper infrastructure to avoid that. And they're storing lots of that data in Elasticsearch. Okay, and then came Beatz along, the nice little fish. Why did Beatz come along? Logstash is very nice, but it's written originally in Ruby, and it's now running in JRuby. But as everybody knows, the JVM needs quite some memory and also has some overhead to start up. So you don't want to put a Logstash on each of your servers. Especially if you have many small servers with microservices running, you don't want to add the overhead of having Logstash on each single one of them. So now there's Beatz. It's written in Go. It compiles down the native system binaries, which makes them much nicer. And these are more like simple, very lightweight agents you can put on each of your servers. And these will then collect data and send it over either directly to Elasticsearch or to Logstash to do some enrichment for you. And so we had the Elk, and now we had Beatz in addition. And then we were not sure how to call the thing. So at first we thought about the Belk or Elk bee. And you can see it's a bee and it has the horns of the elk. And it was a very nice mascot, but it didn't really work out marketing-wise. Also because there was this thought, what if we add another product and we get another letter in? And it's getting more and more hard to find the right animal for that. So we had to kill the elk, unfortunately, and the Belk as well. So presently, we just call it the Elastic Stack, which might be slightly confusing since, like I said, Elastic is the company, Elastic Stack is all of the products, and Elasticsearch is just the data store where you actually search. So this is what the stack now looks like. Every now and then, people come up and say, now, is Beatz actually replacing Logstash? It is not. Those are kind of brothers and sisters. They often go hand in hand, but you don't always need both. So if you ingest some data and you can input it into Elasticsearch directly, that's fine. But if you have any kind of enrichment you need to do, at the moment you need to forward the data from Beatz to Logstash, do the enrichment here, and then insert the data into Elasticsearch. For enrichment, I mean stuff like you have IP addresses and you want to have the country or the region behind those IP addresses. So you would ingest your Apache or Nginx log file with Beatz, send it over to one or two centralized Logstash instances. They are probably running on their own servers, so they don't impact any of your other systems. There you can do the lookup, so you have a geodatabase in the background, and then you can simply say, okay, this IP address comes from this country, and then you insert that information into Elasticsearch, and on top you can query that with Kibana and for example, query like, give me all the visitors coming from the Netherlands, just to visualize that. And just to visualize the architecture a little bit more, you have the different beats. These can either go directly into Elasticsearch or to Logstash, which then forwards it to Elasticsearch. And with Beatz, these are very much focused on one single use case, whereas Logstash is more a bigger system, which has something like 200 plugins, so it can do lots of stuff, but of course, lots of stuff have some overhead. And the Beatz are just focused on one single use case, and you need to install each one of them independently if you want to use them. So we have FileBeat, which is just glorious tailf. So you have your log files, you're reading them, you're sending them over to probably Logstash to parse them into different pieces. Then there is TopBeat, which is just top, which you know from Linux. So it will gather the CPU, memory, and the I/O statistics of your instances, parse the data, and you can insert that directly into Elasticsearch. And then there is PacketBeat, which is just like Wireshark. But again, if you have your microservices and you touch many different servers, you need to capture the package on each of those servers, then you need to merge those logs, correlate them, and then you can analyze them with Wireshark, which is painful. So PacketBeat helps out on that. PacketBeat just copies the network traffic away and analyzes the packets, and it has analyzers for your default protocols you would expect. So HTTP, DNS, different database protocols, and it can just extract information just from the headers of these packets. So for example, for HTTP, it knows, okay, this is the request that is coming in, and this is the response going out. And it can then know, okay, this was a 200 response, it took 500 milliseconds, and it can store all of that data, and you can afterwards graph it out with Kibana. So you can see, okay, I had 95% 200s on my HTTP requests, 2% 400s, and 3% 500s. And then you can dive into those 500s and see what is actually going on. And you can also visualize the timeline, how long did my requests actually normally take. And there you can see, okay, most of my requests are pretty quick, but some are outliers, and now I need to search for those requests taking more than, let's say, 3 seconds, and just try to work on them. And you don't need any complicated logging system or anything on that. You just install a Beatz, which is a DBN or RPM package. It also works on Windows, and that will simply gather those metrics from the network traffic and send it over to Elasticsearch, where you can search it. And then we have currently experiments. Rashid, the guy who actually started Kibana, is working at the moment on Timeline, which is a time series visualization. So you have different information, and you can just graph it one against each other. One example would be that you can graph gross national products, you can sales, whatever you want to match against each other, you can simply put that in Timeline and visualize that against one another. And you have also integrations into external services, so you can pull in data from other sources just to visualize stuff. And it's currently a research project, but Rashid is working full-time on that now to bring or to make that a proper product you can use. Okay, so all of the stuff I've talked about so far is open source. And the obvious question is, where are we making our money? So there are 3 areas where we are making money. First off, if you don't want to host anything yourself and you just want us to do it for you, we're happy to do it. We have a cloud service running on AWS. You simply need to sign up and click a few buttons, and you have a working cluster up and running. And we will do the backups for you, we will do security updates, and every upgrade is just 1 click away. So we can do that for you. The Elasticsearch I've talked about, this is all open source. And what some of our competitors are doing is like they have an open source version of their products and a commercial version. And the commercial versions are often better and have more features, but we don't believe in that. First off, we don't want to make a product and then make it worse to throw out to the community. And secondly, testing is a big issue, because normally you would just or mainly focus your testing efforts on the commercial version because you have the paying customers there, and then dumb it down or make it worse and throw that out to the community. And we don't really like that. Also, some of the products make it pretty hard to switch from the open source to the commercial version. And once you're on the commercial version, your data is kind of taken hostage, and you would need to somehow back it out up and then re-ingest the data just to get it up and running with the open source version again. So we just have, even for paying customers, we just have the same versions everybody can use for free. But we're now having Expect, which are our commercial plugins. But these are only plugins, so you can just use the same open source version everybody else is using. And if you need, for example, security or some alerting, you can simply hook that into the existing Elasticsearch cluster, and you don't need to make any changes. So authentication and authorization is a commercial extension. You can, of course, put an HTTP proxy in front of your server and just do basic auth and SSL via that. There's even documentation from us to do that. But if you need a proper solution, including LDAP, authentication, single sign-on, or whatever you want to have, we provide that for you. Or if you want to have alerting. For example, you either know my cluster is in a bad state and I want to be alerted on that, you can buy that. Or if you have some business metrics upon which you want to have an alert. For example, if you have 1,000 sales in one day and you want to send an alert for that, like hooray to your Slack channel, you can do that with alerts. So the alerts include stuff like email, Slack, PagerDuty, just to keep you up whatever there is in whatever data you have in Elasticsearch. So you don't need to actively go in and search for it, but you can be alerted for it. And then there's monitoring of your cluster, and Graph is pretty new. We'll do a very short demo on Graph later on. Okay, so this was kind of the current state, and the future is coming up next, version 5. So at the moment, it's slightly confusing because each of the components has had a different history and a different version number at the moment. So with Elasticsearch, we're at version 2.3, and Kibana is 4.5. And we would have a compatibility matrix where you would need to look up like this version of, so this product needs this other version of the other products to work well together, which is confusing, and we want to get rid of it. And since Kibana is at version 4.5 at the moment, the next available major version is 5. So all our products are going to version 5 with the next release. So Elasticsearch, for example, is jumping from 2 to 5. And as you can see from the version number, is now much more mature, because 5 must be much better than version 3. Yeah, but it should make life for everybody easier. So the switch is slightly confusing, probably. But from now on, you just have 5.0, 1, whatever, and you know, okay, all the products with that version number will work well together. Secondly, we will have ingest nodes. So we have had Logstash, and some people say, yeah, Logstash is nice, but I don't want to have this additional component. I have just Beatz, which is gathering my logs, for example, and I just need very simple rules just to parse it apart. So very simple grab patterns, and I want to have that IP lookup. So in Elasticsearch, we're now adding ingest nodes. So this is just an Elasticsearch node, but it can do some very simple stuff Logstash was doing in the past. Again, Logstash is not going away. There is no other integration into queues, into Twitter, and many other protocols. It's just like to take some of the burden away. So not everybody needs to run Logstash, since it's maybe you just need one tiny use case of what Logstash is doing, and you can now cover that both with Beatz and Elasticsearch, the combination, and don't need to run Logstash if you don't want to. And because many people have been asking for it, there is now, we call it Cloud Enterprise. This is just something you run on-premise on your own hardware, which is important for insurance companies, banks, big guys with too much money. They just want to run stuff themselves, and they now can. We just provide the same nice interface we have for our stuff on AWS. You just get the same interface to run it in your own data center. So it's just like one click to upgrade, a few clicks to set up the backups. Whatever you need, it's just a few clicks, and you don't need to have the expertise in your own team. Okay, so enough talk. Let's jump to a demo. If you want to run this yourself, simply get the demo from this URL. It's a Vagrant box. You just do Vagrant up, and then it will install all the dependencies and configure them for you. And you can simply get going like that. There is the master branch is currently on the stable release, but I'm showing you off a branch called V5. So this is the upcoming version. We're currently at Alpha 2 of the next version, which will be released like late summer, sometimes the second or third quarter of this year. So you can just try that out. So if you want to play with the new stuff, go to the V5 branch and get everything up and running. And like every good cook, I have kind of prepared this already, because otherwise it would take too long just to download everything. So this is Kibana in version 5. For those of you who have used Kibana in the past, it's now a bit more colorful, and the navigation has moved to the left-hand side. So now here on the left-hand side, you would have all the things you can do in Kibana. I assume it's big enough for everybody to read, right? Even in the last row? Are you fine? All good? Perfect. So first off, you have Discover. And here, I'm just switching the time frame. I'm just not doing the last 15 minutes, but I'm still say, okay, I want the week until today. So let's see. it's now aggregating my log files, and you can see the week to today from FileBeat. So I'm just ingesting from the virtual machine. I'm just ingesting the local log files from that machine, and I have 4,000 log events when I'm searching over all of them. And you can see, okay, here I've been doing some big stuff because it's just over 2,000 events, and again here. And of course, I can just zoom into one specific time frame, for example, this one here, and you can see, okay, every now and then I've started up my virtual machine, something has been logged, and then here I've probably shut it down, and here again I've started it up to test some stuff. So for example, if I want to know when did I reboot my machine for the last time, I would simply search for reboot here, and obviously in that time frame I haven't rebooted my machine. So we'll switch back to the week to now. And you can see, okay, 2 hits. I have rebooted my machine on May the 7th and May the 10th. And down here you can see the actual log file. So I expand that one here. You can see all the different fields I have passed apart from my log files. So I can see, okay, this is coming from the host. Yeah, with one virtual machine, it's not that interesting, but you can imagine if you have like 20, 50 or more servers, it will be relevant where your stuff is coming from. And you can, of course, only search for specific servers or groups of servers. And then you see, okay, it was from this log file, and the actual log message was whatever rebooted my server. And here you have the other log message. And you can simply see, okay, this is what's going on in my cluster. And next up, what is very fancy with the different Beatz, you get pre-built dashboards which you can simply open. So here I have, for the last week, I'm showing you top beat, so just top, what is my cluster doing. You can see the system load. Probably here I've installed something because the load was much higher, and since then the load was pretty low. You can see, okay, the disk usage seems to be pretty stable, and like most of my devices are not that full, so it's pretty much okay. Going down, you can see the overall memory usage is pretty high. Maybe I will need to add some memory soon to my instance. And CPU usage is also like sometimes pretty high, but overall okay. And here you can have the different components we have and see how each of them are doing. So you see, CPU-wise, Java is using lots of CPU. So when it comes to programming languages, we are pretty pragmatic. So Elasticsearch is written in Java. That's what's eating up most of my CPU. For memory, you can again see, okay, Java is using lots of that. But Node is also taking up lots of memory. And Kibana, the visualization, is written in Node. And then you can see PacketBeat, gathering the network packets, also uses some memory. And Ruby, which is Logstash, is taking up very little memory. And Puppet I'm not actually using, that's just coming with the VM, so that's, yeah, not all that sensible. And here you can see, okay, these are the different processes. So Elasticsearch, Kibana, TopBeat, PacketBeat, FileBeat, those are all the beats I've installed, and you can see, okay, how much CPU are they using, or what's the maximum they're using, how much memory are they using, and what's the percentage of the memory they're using. And also, like, where is my disk space going? So you have all these visualizations with TopBeat, and there are some other visualizations for Beatz as well. For example, if I want to have PacketBeat HTTP requests, I can see, okay, over the last week I had not that many requests, since it's only my local machine and only when I do a demo I will have requests. But here you can see, okay, we have had nearly 400 requests from 9 to 12, because this is a 3-hour aggregate. So I was probably running some demo to show that off yesterday. And you can see, okay, overall I've had nearly 2,000 requests. Most of them were 200s, at least for the most popular pages. But here I've had a redirect 304. And you see all the errors I've had were very few of them. I've had like more or less all the error codes just happened a single time. One redirect, one 400, one 401, 404, and one 500. And you can actually see when did they happen and how many. So you can see, okay, maybe you did a deployment at some point, and if you see the 500s go up dramatically after that point of time, you know, okay, that was a bad deployment. I will probably need to roll that back. And then you can, for example, see the top URLs you're accessing. And to get the general overview over packets, you can simply switch to the packet beats. And once it has finished loading, since it's just my poor little VM with 2 GB of RAM and it's loading all the components, okay, I don't have that many client transactions, and I don't have a database running locally, but if you would have, you could see all the metrics for that down here. So with web transactions, you can see, again, that was the metric I've shown you. If you had a database or a cache or some RPC service, you could see all those requests as well. And you can see the response time depending on time, or like a bit more down here, the error codes versus the success code. So you can see, okay, I have had lots of errors here, and you will need to check out why. And also response times, you can see, okay, the 99th percentile is sometimes pretty high. This is like more than 4 seconds for like 99% of your requests, but the 75th percentile of most requests is doing well. I was on bad Wi-Fi's, and some of the stuff was just slow locally, so don't worry about that. And you can simply see, okay, how many requests and how many errors did you have, and you can see most of the bad requests were actually DNS requests, bad ones, which might be an interesting input if you have that on your servers and you want to look into why are your DNS servers doing that badly. And here you have the latency histogram, and you can actually see like most of the requests are super fast. Just we have some outliers here where you have like one request that took more than or nearly 3 seconds, and you could probably find, yeah, the slowest request I've ever had on that system now was nearly 8 or more than 8.5 seconds. Not all that great, but yeah, that's just to dive into it. And just to show off timeline quickly, so you can simply, let's take that away for a moment. Say, okay, graph me all the data I have in my cluster, and then you can see, okay, I don't want to show the stuff from the last 50 years. I just want like 1 week again. And the proper time frame is probably hours for that. So here you can see, okay, every now and then I've stopped my machine, and then I'm starting it again, and then you can see, like, these are all the data I've inserted into my cluster. And then you can filter that down, for example, if you're just interested in what you're logging. Here you can see, okay, here we have a jump in log files we've produced. Probably you want to dive into those just to know what has actually happened in my system. And then you can also correlate those with packet beat, for example, with your network packets, just to see like what is going on. Like, do my logs correlate somehow between where my files have jumped up to the network traffic? And you can see, yes, network traffic and log files somewhat correlate. And since you cannot really tell which is which, you can also add stuff like labels. So this would be packet, for example, and you would then just see, okay, these are my network packets, and you can hide and display them and just throw that out with timelines. So you can very easily draw your timelines here. And finally, because there was a request to show off the Graph API. So the Graph API is pretty new. It was added in version 2.3, and this one, as you've seen in the overview slide, is one of the commercial plugins. We are not really trying to compete with graph databases like Neo4j. This is more to explore existing data and kind of get an overview of what you have in your system already. So it's just using the data you have already inserted into Elasticsearch. You don't need to add any additional database technology, or you don't need to add any indexes. It's just based on the data you have. And here, for example, I have loaded the last.fm user data. and I'm searching for artists. And here I've searched for Mozart. And you see Mozart is here. He's very strongly connected, for example, to Johann Sebastian Bach and Ludwig van Beethoven, what you would expect. But what you probably wouldn't expect is that Mozart is also connected to the Beatles and Coldplay, which is kind of strange. But the answer to that is the Beatles and Coldplay are just so super popular that nearly everybody listens to them or likes them. So this is why they're always showing up in each and every data set. But they don't really make much sense for that use case here. So since, like I said in the beginning, databases are very much like black and white. There is data, there is no data, and full text search is more on these shades of gray. There's always this quality attribute. And I've, for this demo now, disabled it, but we can actually enable this feature for the graph based on Elasticsearch as well, where we just say, we're not interested in these hot nodes that appear in every single data set because they add very little value again. We just want to add the most relevant hits we have in our data set. So if I go back and say, only show me the significant links, and I rerun my search, my session has expired now, come on. Sorry. Okay, we'll need to find Last.fm. We want to use for artists, and I'm searching for Mozart, if I can spell his name correctly. We've now enabled the correct link weighting, and you see the Beatles and Coldplay are gone, and now you just have Schubert, Bach, van Beethoven, Haydn, just the stuff you would actually expect because they are the most relevant and they are not like super connected to all the different bits and pieces. So this is the idea of graph, just to like find in your existing data the relevant pieces of data. And you could, for example, use that to search like different countries, so what are the people in the UK are listening to and what in France, and then you could also compute the overlap, like which artists or bands are both popular in the UK and France, and that overlap is actually pretty small. Yeah, but since we're running short on time, let's conclude. So we've talked about the Elastic Stack. These components are all open source. You can just use them for free. If you need support or anything, we're here to help and happy to jump on that. And yeah, Logstash is the lightweight agent to ingest your data. Beatz is the lightweight agent. Logstash is doing the heavy lifting and integrates many different parts and parses that and enriches your data to insert all of that into Elasticsearch. Full text search, where you can efficiently search for stuff and then visualize it in Kibana on top. And if you want to try it yourself, that again is the link. Just do Vagrant up, run it yourself, give it a try. Reach out to us if you have any problems. Yeah, any questions? And don't forget, stickers. I haven't brought up the stickers here, but if you're going for lunch or anything, we're right next to lunch. Grab some stickers, and we're also raffling Lego tech. So come with your badge, we'll scan your badge, and you will be in the raffle, and it's, I think, at 4:15, we will actually find one lucky person to give it away to. Okay, any questions? Yes, please.
We saw a picture where you showed how Beatz, like file banks and everything. In the last there was your beat, something that you can customize and complement the data. So what are the options there?
So all our beats are based on a library called libbeat, which is the basic. And then you can just take that libbeat and build your own beat around that. And I've just shown 3 popular beats provided by us, but there are also already quite some community beats which you can use. So people in the community have built upon libbeat to build their own beats. Simply search for them. For example, there is a Docker beat where you can just from the host monitor all the Docker containers you're running on a server, and there are many different beats people have written. So it's pretty easy to get started. You just need some Go knowledge, and then you're good to go.
And you said when you were showing the commercial slide, you said that for alerting you would have to buy Stack.
Yes.
Just we need alert
At the moment, no. I mean, you can always talk to the sales guys, and I don't even know the prices, so I cannot really say anything authoritative on that. But in general, it's XPack and support. It's just like the full package you will always get as a package. And then it's a license based on a node base. So you get like 1 to 5 nodes, 5 to 10 or something like that. But yeah, if you're interested in that, give me your card. We'll send you over to sales and discuss that with them. I'm just like the friendly guy. I'm showing off the open source stuff you can use for free. I'm not selling anything. Yes, please.
So Logstash seems to have GitHub support. I thought I saw it mentioned on the slide.
One of the...
And what does that entail, and do you have Bitbucket support as well?
I'm not sure about Bitbucket. Maybe somebody wrote the plugin themselves. It's possible. So it's just like you could react to events coming from GitHub. So just like somebody pushed some code, somebody, I don't know, opened an issue. Yeah, you could just take that in and put that in Kibana to visualize. So in your office, you just have a graph with when do people push. So just to keep the team motivated, or how many open issues are there at the moment. Just to get in all that information to visualize it, that is just one common use case you could do with that. Any more questions?
Same for Logstash. Can we come in our own way in Logstash? Like there was your week in Beatz. Is it possible?
Sorry, once again.
Like in Beatz, you said you can write your own thing with your week.
Oh yeah, you can write your own plugins for Logstash.
Okay.
I mean, there are like 200 or so at the moment, but of course you can write your own and hook that into it. It's Ruby, and some small parts have been rewritten in Java for performance reasons, but generally if you can write Ruby, you can write your own plugins. So maybe there's a Bitbucket integration, maybe you need to write it yourself, but it's doable in general. Okay, if there are no more questions, I'm down at the booth for the rest of the day. Just come down if you have any questions, if you want stickers, or if you want some Lego tech. Thanks.